Hey everyone, still in lesson 10, still in level 6, choosing your own adventures by writing algorithms. Usually they're multi-select statements, so we've done fashion trends and internet access. Let's check out valid credit cards. Oh, there could be a look. Oh, see, notice there's no text things in here today. There's no text files. So a credit card company needs a program that checks if credit card numbers are valid. They want to use the Lugana. Oh, what is this? The Loon algorithm uses identity verification. Oh, what is the Loon algorithm? Some mathematical formula. How does it work? Oh, I have to read this for my cybersecurity kids. Anyway, let's go back. The card class has an instance variable for 1D array containing the digits of a credit card number. The validate number returns true if the 1D array contains digits of a valid credit card number and false if the digits are invalid. Got it. And then we're going to come back to the, in the company Java, we're going to write the validate number method. All right. Oh, parity bits. We're going to do a little method. Okay, so we'll come back and look at this. So let's take a gander at our, like all of our stuff in here. So in the card runner class, there is a company object. I don't know what the company object does, but it's a new company with nothing that's being passed to it. Interesting. There is an integer array called validate card number at 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 0. And then there is a card object called valid card. And then this object has the valid card number passed to it. Here's an invalid card number. So, okay, I got it. So these numbers here make up a valid card. These numbers here make up an invalid card. And again, it's still, even though it's an invalid card, it's still a card object. And it's a new card that gets the invalid card numbers passed to it. I don't know. I wonder. I don't think there would be any scanner class in this. So let's take a gander at the company class. So this is what we are going to do. We're going to implement the Loon algorithm. Oh, so they do explain what the Loon algorithm does here. So that seems pretty good. I don't think it'll be too challenging if we just follow the instructions carefully. And in the card class, there's one private instance variable, which is an integer array called digits. And there is your constructor. And there's a get digits method, which gets that 1D array. And there's a toString method that has been overridden. Good. All right, so let's go here. Let's give this a try, shall we? Let's give this a try. I'll zoom in, see if it makes it easier to see. So this method is going to turn true if the credit card digits are valid. Otherwise, it's going to turn false. So I want to get the parity bit, the remainder after dividing the length of the array by 2. And then I want to traverse the 1D array digits from last to first. Well, first let's get the parity of the length of the array. And I'm assuming that array is, oh, that's a credit card object. So I'm going to have to get the array. So let's try this. So this is this will be an int, and I will call it parity equals, and I am going to take that credit card object that is being passed to it. I am going to get the digits. I'm going to get the digits and then I want the length. I don't think I need to get the digits. I don't think I need to get the digits. I just need the card. I guess I do need digits because digits is a 1D array, so I am going to need that. I am going to need that. So I'm going to go get digits, and then I want the length of that array. And what I'm going to do is I'm going to mod this out. I'm going to mod by 2. And so that should return either a 0 or a 1. If the length of the array is even, parity will be 0. If the length of the array is odd, parity will be 1. And then we want to traverse the 1D array digits. And so 4, and those digits, so int a digit in credit card dot get digits. So because in the get digits, that returns a 1D array of the digits, and that's what I want to do. But I want to go from last to first, so then I can't use an enhanced for loop. I will need to use a regular for loop. So let me go for int I equals, and what I want is credit card dot get digits dot length, and I that's what I want it to -1. Yes, it needs to be -1 because there is no index equal to the length. So I'm going to go -1, and as long as I is greater than or equal to 0, and then I want to go I minus minus. Okay, so that's going backwards through the array. Now, if the current index mod 2 does not equal the parity bit, add the digit at the current index to the sum. So, to the sum of what? To the sum of what? Let's see, did I miss something here? Let's see. So I think I probably need to have an integer sum, and so I guess I need to go int sum equals 0 somewhere. Let's see. Okay, so because that's what it says, and so as I go through those digits from last to first, if the current index mod 2 does not equal the parity bit, add so if I wonder if I could, nope, it's okay. Credit card dot get digits. If credit card at the current index, if I mod by 2, and it does not equal the parity, add the digit at the current index to the sum. So what I do is I want to take this, I want to take sum equals sum plus this. Not the whole thing. I just want to add the digits to it. Got it. All right. So I did that. Else, if the digit at the current else, oh, it's else if, so I don't want to just go else. Else if the digit at the current index, so this, if that is greater than 4, add the result of, okay, I will do this. I am going to take sum equal sum plus this stuff here. Actually, since they've already given me sum there, so I just need to add that stuff there, 2 times the current digit. Oh, so I need to go up 2 times, I didn't mean to do the current digit. What I need is 2 times this. If the remainder of dividing the sum by 10 is true, sum is 0. So in other words, if the sum is not a big deal, not a big deal, so where's my return? So what I want to return is, I just want to return so it says return false. So let's see. If, I'm going to go here. So if sum mod 10 is equal to 0, I want to return true. Else I'm going to return false. Boy, if this works, I'm going to be stunned, because there's a lot of moving parts there. And I think what I could have done to make it easier to read, I probably could have defined that kind of by itself. But that's okay. I'm just jumping into it the first time and going through it. I think everything else is okay. Now, I'm sure there'll be plenty of errors. Sure, there'll be plenty of errors. But, all right, is that it? There's nothing left to do. Nothing left to do. What happens here? All right, let's run it, see what it does. I really don't know if it's going to work or not. Parity. So cannot find symbol parity. Okay, got it. Oh, that's probably, parity. And I spelled that parity. And let's see, it doesn't like that in 16, but let's give this a try. So I can fix this one. It's parity, so I'm going to take that out of there. And somewhere in line 16, see if that does a trick. Huh, that'd be doggone. Let's run the test. Will the test work? No. So I messed up something on here, but I'm really not too worried about it, because, man, there's a lot of moving parts. I got it to run, but I will see if I can figure out where there might be an error. But you know how that testing goes. Because I'm surprised that they are both false. Yeah, kind of surprised that they're both false on this. But I will go back over this and look over and see what I might have done. Oh, maybe, let's see, if the current index mod 2 does not equal the parity bit, add the digit at the current index to the sum. So that's at the current index. I did that. If the current index is greater than 4, add the result of some. Oh, no, I think add the result of this to the sum. So I think I do need a sum plus here. Let's run this and see what it does now. Still. Yeah. I mean, it ran, but expected to, but it returned false. So I wonder why. Oh, -9. I didn't see the -9 there at the end. See, so I want to go -9. Let's see what happens. Oh, wait a minute. That's also not true. Hold on. Let me try this again. Ready? So, if the credit card, add that. If the credit card is greater than 4, add the result of this to the sum. So I added this to the sum. That's my new sum. Else, oh, I did not do the else statement, did I? Else, sum equals this. Sum plus sum. So it's kind of what I had up here. All right, now let's see what happens. Oh, of course, did I forget a, what did I forget? Oh, of course, a semicolon. Still, what? All right, I'm done. I will look at this later and make sure and go back over this, but I just got to follow that very, if the remainder of dividing the sum by 10 is 0. So if I take the sum, divide by 10, and that's equal to 0, I want to return true. Otherwise, I return false. The only thing I think I could do here is I could do something like this. Plus sum, that should not matter. This is going to bug me now. You guys know this is going to bug me. 2 times the current digits minus 9, or just 2 times the current digit. It runs, just doesn't run correctly. So I'll figure it out.